This lab is similar to the last lab in that you're going to heat a sample to remove the water so that you can calculate the ratio of water to compound, the water of hydration. However, in this lab, we're going to go farther and also identify the compound's formula by calculating the ratio between the elements within that compound. Now, the reaction between copper ions in solution and the aluminum ribbon will take a fairly significant time. Now, it'll take less time if there are more aluminum atoms available on the surface of the aluminum ribbon for reaction. So you want to maximize the surface area of the aluminum available to the copper ions in solution. This means that you don't want your aluminum ribbon sitting flat on the bottom of the beaker, because in that case, the glass will effectively be covering one surface of the aluminum ribbon. But if you instead curve your aluminum ribbon into the shape of a C, you then will have both faces, the inner face and the outer face of the aluminum ribbon, available for the copper ions to react with. Now, over time, the copper will precipitate onto the surface of the aluminum as the aluminum ions react, and the copper steals the electrons from the aluminum. So as the copper plates out, it will slowly cover up the surface of the aluminum. And you're going to want to take your glass stir rod and gently scrape off the copper from the surface of the aluminum. Now, again, you want to use the glass stir rod. You don't want to use anything else that's metal, like your scupula. Use the glass stir rod, and you don't want to use the rubber policeman end. You want to use the glass end. Now, that glass end is going to be rounded, and so it's not going to be the best at scraping. But you're going to do your best to scrape along the aluminum ribbon to knock the copper off to maximize the surface area of the aluminum available for the reaction. And in that way, you'll maximize the reaction rate and minimize the time that the reaction takes to occur. You're going to want to do that about every 30 seconds to a minute or so. Now, after the reaction, you're going to perform a filtration. During that filtration, you'll use an apparatus that looks something like this, where you have a flask. Note this is not an Erlenmeyer flask. It's a very related piece of glassware, but it has this side arm here. That side arm has a hole in the side and allows us to attach a piece of rubber tubing, the vacuum tubing to the side. We can connect that other end to the sink aspirator to provide suction and decrease the pressure in the flask that then forces the liquid through the filter much faster. Now, with that rubber tubing is fairly heavy, and so without doing anything else, this will have a tendency to tip the entire apparatus over. And this is why we want to make sure that we have a utility clamp clamping onto the flask and holding it in place, and then putting it on our ring stand. Also, we have our Buchner funnel, this ceramic funnel, in place. Inside the Buchner funnel, we have a piece of filter paper. We want that filter paper to cover the entirety of the holes inside the Buchner funnel. And in between the Buchner funnel and the glass of the sidearm flask, we have this rubber adapter. If you don't put that rubber adapter in there, you won't get a nice airtight seal between the flask and the Buchner funnel, and the vacuum won't really be doing much of anything because you'll just have air escaping, entering the flask from the outside rather than through the filter paper. So make sure you have that rubber adapter in place. Now, once you have your reaction mixture on the filter, you will want to rinse it. The procedure describes rinsing it with 2 8 milliliter aliquots. Now, an aliquot is just a portion. So by 2 8 milliliter aliquots of distilled water, it means you are using 2 8 milliliter portions of water to rinse your copper with. Now, at the end of the filtration, you then have to remove the filter paper from the Buchner funnel with the copper on it and get all of that onto your watch glass. The best way of doing this is by inverting the watch glass, putting it over the top, and inverting the entire setup. If you're lucky, the filter paper will have popped out with the copper underneath it. The fact that the copper is underneath won't matter. All we care about is the mass of the filter paper and the copper. If you're not quite so lucky, you may have to kind of tap the Buchner funnel onto your watch glass, or possibly even use your scupula to gently scrape the filter paper out of your Buchner funnel. From there, you're going to take your watch glass and filter paper and copper and put it into the oven to dry it. Now, when you go to remove the watch glass, of course, it's going to be hot, so you don't want to be touching it with your fingers. So you'll use your crucible tongs to hold onto the watch glass, but you should also wear a pair of gloves in your non-dominant hand. So I am right-handed, so I'm using the crucible tongs in my right hand. The glove is on my left hand. I'm grabbing the watch glass with the crucible tongs, and then I'm going to hold my gloved hand underneath the watch glass as I walk back to my lab station. So let's talk a little bit about safety hazards. As we already alluded to, we're going to be using heat. The crucible is going to be very hot. So use the crucible tongs to handle the crucible and the cover after you heat it. Again, use the crucible tongs and the gloves to carry the watch glass back to your lab station from the oven. Also, hydrochloric acid is severely corrosive to human tissue. You want to be very careful not to spill any on yourself. If you do get any hydrochloric acid on your skin, wash the affected area immediately, and if you spill any on the bench top, consult with your instructor or your TA, teaching assistant, for the best method to clean it up. Additionally, the unknown copper chloride is toxic to humans. If you get any on your skin, wash the affected area immediately.